Hey everyone. So we're gonna run through 7.4. I'm making a second version of this short lecture because the background noise in the first version of this isn't the greatest. So in this lesson, we are going to cover the other trigonometric functions. What do I mean by other? Our cosecant, secant, and cotangent functions dealing with our famous angles 30, 45, 60, 90. In terms of radians, pi over 6, pi over 4, pi over 3, pi over 2. These first two objectives are going to seem very familiar, especially because we tackled this using our sine, cosine, and tangent functions, but now we're just going to utilize their reciprocals. The new material that we're going to cover are mostly in our objectives 3 and 4, looking at trigonometric functions and identifying which ones are even and odd, and then adding more fundamental identities when it comes to trig. So finding exact values of trig functions. If we were looking at a unit circle and we had a point xy on our unit circle, think about this again in polar coordinates. We have our cosine of t comma sine of t. And then think about if we have this unit circle, us drawing in our right triangle and looking at our proportionalities of sides. This is our x, this is our y, so y, x, and 1. That's how we get all of these, utilizing our SOHCAHTOA, and then understanding that our secant, cosecant, and cotangent are just the reciprocals of cosine, sine, and tangent, respectively. So let's tackle this first example together. We have the point negative square root of 3 over 2, comma 1/2, and we just want to find the following, all of our 6 famous trig functions. Lucky for us, x comma y, which is given to us, our x and our y, is the same as our cosine of t and sine of t in polar coordinate form. So this tells us that our cosine of t is negative square root of 3 over 2. Our sine of t is 1/2, right? 2 down, 4 more. What about our tangent of t? Well, let's utilize our knowledge of SOHCAHTOA. If our cosine is adjacent over hypotenuse and our sine is our opposite over our hypotenuse, our tangent is your opposite over our adjacent. 1 over negative square root of 3. Rationalize the denominator. And I like to bring the negative to the numerator. And we end up with negative square root of 3 over 3. Halfway there. Now let's just look at the reciprocals. Reciprocal of cosine of t is secant of t. Flip it and we get negative 2 over square root of 3. Rationalize the denominator and we get negative 2 square root of 3 over 3. Reciprocal of sine t is our cosecant t. Flip 1/2 and we get 2. And then the reciprocal of tangent is cotangent. And so flip this and we get negative square root of 3. And we're done. Let's continue. So now we're in our example 2. Very similar question, but we're given our angle measure. Our t is pi over 6, which is the same as 30 degrees. And we're asked to find our sine of pi over 6, our cosine of pi over 6, tangent of pi over 6, and then the reciprocals. So our cosecant of pi over 6, secant of pi over 6, and cotangent of pi over 6, right? Sine of pi over 6 is just 1/2. Cosine of pi over 6 is square root of 3 over 2. Tangent of pi over 6 is just 1/2 divided by square root of 3 over 2, which is 1 over the square root of 3. Rationalize and we get square root of 3 over 3. And now let's look at the reciprocals. Cosecant of pi over 6 is just 2. Secant of pi over 6 is 2 over square root of 3. Rationalize the denominator and we get 2 square root of 3 over 3. And then cotangent of pi over 6 is just square root of 3. I feel like this was the same. Yeah, I feel like we got very similar values. The only difference is some of them were negated in example 1. Okay, and that's it. This next slide, we have now the full table. Remember in our last section, I went over our cosine, sine, and tangent table with you guys. Now we are fully capable of adding in those additional rows. And so now this moves on to our second objective, really using our reference angles with our reciprocal famous trig functions. Our reciprocal of sine, which is cosecant, our reciprocal of cosine, which is secant, and then our reciprocal of tangent, which is cotangent. This is another slide really formalizing where our certain trig functions are positive depending on our quadrant versus where they are negative. I highlighted this a little bit in our last lesson or 2 lessons prior, but once again, all students take calculus is the acronym to remember this. Our first quadrant, all trig functions are positive. Our second, only sine related trig functions are positive, so sine and cosecant. In our third, only tangent related are positive, so tangent and cotangent. And finally, in our fourth, only cosine related functions are positive, so cosine and secant. And so now let's tackle example 3 together, where we want to use reference angles to find all of our 6 trig functions of negative 5 pi over 6. So what is our reference angle here? Negative 5 pi over 6 ends up going right over here. Which means our reference angle is this guy over here, which is pi over 6. And now we just want to find our 6 trig functions evaluated at pi over 6, which we already did. So I'm just going to take all of this and then I am going to move it over to save time. And then we also need to utilize our acronym, all students take calculus. Because we're in that third quadrant, we need to look at all of our tangent-related functions, keep those positive, but every other one is going to be negative. So sine is negative, negative. Um, we can put them in front here too. And there we have it. Our third objective is reviewing our knowledge of even and odd functions, but now from a trig perspective. And fun fact, our only even functions are cosine related. So cosine of x and secant of x are our only types of even functions. All sine related and all tangent related functions are odd. And we can use our definition and plug in for each to prove which ones are even and which ones are odd. For sine, if we plugged in negative t, we would spit out a negative y, which tells us that sine of t is not equal to sine of negative t, therefore it's not even. Sine of t is equal to negative sine of t, which means it is an odd function. And then each box checks out. So we formalize it and we state, okay, all of our cosine related functions are even. Maybe I'll highlight this. Green for even. And all of our sine and tangent related functions are odd. So now let's tackle example 4 together. Secant of t is equal to 2. Well, we know secant of t is an even function, which tells us that secant of t is equal to secant of negative t, which is what we're trying to solve for. But if we know secant of t is 2, then we get our answer as secant of negative t equals 2, and we're done. Example 5, we're asked to find the exact values of each of these following problems. So part A, sine of negative 45. Sine is an odd function, so this is the same as negative sine of positive 45, which is simply negative square root of 2 over 2. Part B, cosine is an even function. So cosine of negative pi is the same as just cosine of pi, which gives us negative 1. Cotangent is an odd problem. So cotangent of negative, or an odd function, negative 120 degrees is the same. I should really put the degrees in for the first one too. this is the same as negative cotangent of 120 degrees. Think about reference angle. So this enters into your second quadrant, and your reference angle is 60 degrees. All students take calculus. Only sine-related functions are positive there, which means the cotangent of 120 is the same as negative cotangent of your reference angle 60. You still have that other negative in front. So essentially, we're really looking at positive cotangent of 60 degrees, which is the same as cosine of 60 divided by sine of 60. Cosine of 60 is 1/2. Sine of 60 is square root of 3 over 2. So divide the two, utilize keep, change, flip, and we get 1 over square root of 3. Rationalize, and we get square root of 3 over 3. We're done. And then finally, we have our part D. Tangent functions are odd. So tan of negative 37 pi over 4 is the same as negative tangent of 37 pi over 4. Now let's look at the reference angle. 4 goes into 37 9 times. So we have 9 pi and then an additional pi over 4. But in terms of rotation, we have 1 pi, 2 pi, 3 pi, 4 pi, 5, 6, 7, 8, 9. So we're over here, and then we have another quarter, which means we end up in this third quadrant. With the reference angle of pi over 4. 1, 2, 3, 4, 6, 7, 8, 9. And so all students take calculus. Lucky for us, our tangent is positive here. So we can rewrite this tangent of 37 pi over 4 to be just tangent of pi over 4. And then we don't want to forget the negative in front. Let's zoom in on a little bit more. Tangent is the same as our sine of pi over 4 divided by cosine of pi over 4, which is the square root of 2 over 2 in both cases. And so then you just get -1. And you're done. Our fourth objective is recognizing and using our fundamental identities. And so again, tangent, secant, cosecant, and cotangent in terms of sine and cosine are the following. We are very good with this at this point. And so let's do one more bit of practice before we get into some more Pythagorean identities. So we want to simply evaluate tan of 45, which again is the same as just sine of 45 divided by cosine of 45. And sine and cosine of 45 are both square root of 2 over 2. Just solved this earlier. So we get tangent of 45 is just 1. And we're done. And then part B, we have a radians problem. We want to identify secant. Our secant of 5 pi over 6 is the same as 1 over cosine of 5 pi over 6, which is just 1 over negative square root of 3 over 2. Flip it and we get negative 2 over square root of 3. Rationalize the denominator and we get negative 2 square root of 3 over 3. And we're done. So now we arrive at one more question before the Pythagorean identities, I promise, right? Yeah. And so we want to just simplify this example. Secant of t is the same as 1 over cosine of t, and tangent of t is the same as sine of t over cosine of t. Keep, change, flip, and we get cosine of t divided by cosine of t times sine of t. Cosines can cancel out, so then we're left with 1 over sine of t, which is the same as just cosecant of t. And we are done. Now we arrive at our alternative forms of the Pythagorean identity. So our famous form is our whole sine squared t plus cosine squared t equals 1, or cosine squared t plus sine squared t equals 1. And if we take this Pythagorean identity and divide each term by cosine squared t, then we get another Pythagorean identity, which is our 1 plus tan squared t equals secant squared t. But now if we go back to our yellow and let's say we divide each term by sine squared t instead, then we'll get what's in orange down here. Cotangent squared t plus 1 equals cosecant squared t. So these pop up every now and then, so it's really important to know, but you don't have to memorize them. As long as you have your famous Pythagorean identity, just know, oh, I just have to divide all 3 terms by cosine squared t. Or, oh, I have to divide all 3 terms by sine squared t in order to get my alternate forms of our Pythagorean identity. So now let's tackle example 8 together. We're given cosine of t is 12 over 13, and it's in our 4th quadrant. So all cosine related functions are positive. And we want to find the values of our other 5 trig functions. So what is our sine of t? What is our tangent of t? What's our cosecant? What is our secant? And then what is our cotangent? I think the easiest way is to really utilize our SOHCAHTOA. Cosine of t is the same as our adjacent side over our hypotenuse. So if we put this in terms of our right triangle, we have our angle t, our adjacent is 12, our hypotenuse is 13, which by Pythagorean theorem, that tells us that our missing side is 5, because 5, 12, 13 is a famous Pythagorean triple. So now sine of t is our opposite over our hypotenuse, which is just 5 over 13. But it's important to know that we're in the fourth quadrant, so everything is negative except our cosine related functions. So it should be a negative here. Our tangent is opposite over our adjacent, which gives us 5 over 12. And again, it's negative. Cosecant is the reciprocal of our sine, so just flip that. And we get negative 13 over 5. Secant, we just flip this guy. It's going to be positive, so it's just 13 over 12. And then finally, we have our cotangent. We're just going to take the reciprocal of our tangent, and we have negative 12 over 5. And we're done. Periodic functions. We'll be getting into this a lot more in chapter 8, but it's good to understand what a period is. And so in trigonometry, our period just represents the shortest interval over which a function completes a full cycle. And so if you're looking at a function f of x, this example is saying, okay, f of x plus 4 tells us that every 4 years, right, our units are years here, we have our function repeated. And so, in other words, every 4 years, February is guaranteed to have the same number of days as it did 4 years earlier, aka our period is 4. It goes back to the beginning of the cycle every 4 years. So once again, when we're looking at our trigonometric functions, we will very quickly realize that our trig functions are periodic. They're cyclic. They have cycles that they run through over and over and over again. I'm just going to color code this properly. I'll put this in pink. So the period p of a repeating function is the number representing the interval such that f of x plus p, or period, is equal to f of x. When it comes to trig, put this in orange, we have our period for our cosine and sine related functions is 2 pi. And then our period for our tangent related functions, so tangent and cotangent functions, are pi. Let's tackle, I believe, one last example from this section before we jump into our chapter 8. So we're asked to find the values of our 6 trig functions based off of our angle t. And I'll write out our 6 trig right now to save time. So I wrote them all out. And again, think back to our polar coordinates. This is our x value, this is our y. Well, our yellow is the same as our cosine of t. I got the colors actually wrong. I'll switch them in a moment. And then our purple is the same as our sine of t. Purple, yellow, yellow, and purple. Okay. So now let's substitute it in. That tells us that our sine of t is negative 1/2. Our cosine of t is negative square root of 3 over 2. Our tangent is sine over cosine. So we end up with negative divided by negative is a positive. Rationalize our 1 over square root of 3, and we get square root of 3 over 3. Cosecant is the reciprocal of negative 1/2, which gives us negative 2. Secant is the reciprocal of negative square root of 3 over 2, which is negative 2 over square root of 3. Rationalize the denominator, and we get negative 2 square root of 3 over 3. And then finally, our cotangent of t is the reciprocal of 1 over square root of 3, which is just square root of 3. It makes sense in terms of our positive and negative values, because if we once again look at our acronym, All Students Take Calculus, our terminal side hits into this third quadrant, and in our third quadrant, all of our tangent-related functions are positive. So our tangent and our cotangent functions are positive, but everything else is negative, which is true. So I hope this was helpful and the audio is a bit more clear. We just finished our section 7.4, and next up will be both sections 8.1 and 8.2, which involves graphing our famous trigonometric functions, sine, cosine, and tangent. I will see you guys soon. Take care.